Thank you so much, Clarice, for this introduction. As already mentioned, my name is Kim Albrecht. Maybe before I start my presentation, just some bare-bone introduction. So my background is in graphic design and interface design, but I then worked in a physics lab, in a humanities lab, and I did my PhD in media theory and philosophy. So this talk will incorporate all these different views. So it's quite a lot, but I think there are different things that everybody can pick up. And basically, what this is it's a description of quite a couple of projects that I've done over the past decade. And what I'm looking into is what motivated me to do what I'm doing and why am I passionate about data and visualization, and how also my thinking changed throughout the years of this field, and how data and narratives are coming together. And that said, I have this little supercut, which is basically a collection of images of the things that I've been doing. So you get like some sense of what this looks like. So it's a really graphic work that I'm pursuing. And I will get into a couple of these projects. It changed quite a lot from doing online projects that live on the web, which I'm still doing. But nowadays it moves more and more into things that also live in museums and exhibitions, but also as performances, so embedded within other cultural notions. And I wanted to start this, why data? Why am I interested in data? And I think my entire career somehow evolves around this notion of data. And for this talk, I looked basically back into when I studied graphic design and when I first encountered that as a designer, I was able to work with data. And I wanted to bring you back to that time about 13 years ago, and what fascinated me about this. And for me, data became like a kind of bridge between the world of design where I was studying in, and this notion of science. And I was always fascinated in science, but I never had a particular field that I was like drawn to. It was never that I said like, oh, biology is like the thing that I'm interested in, or physics is the thing. But it was rather this general idea, what is science and how is it acting in the world? And suddenly through data, design gave me a kind of bridge to work with scientists and do work in that realm. And I was interested, or I was fascinated by projects like this one. This is from Aaron Koblin. It's called Flight Patterns. And it was like pretty early visualization. What you see is basically all the flights going into the US and in between the US and going out of the US. And basically this map of the United States emerged from this visualization of coordinates of planes. And visualizations like this, which is like a depiction of the internet. So every node is a website, and then the connections between them are the links and how they're linking. And something similar appeared at the same time in like 2012 from Facebook, where they tried to put every person who uses Facebook and their friendship connections on one map. So you have like 1 billion people or more, and how that basically recreates this image of the world. And at that time, I was fascinated by statements such as this one from the biologist Edward Wilson from 1989, where he said, love for complexity without reductionism makes art. the love for complexity with reductionism makes science. And so that there is some kind of mixture that we can bridge this gap. So there was this like real fascination for data that emerged within me. I was very much drawn to this book by Ryan Hux. If you're interested in design, you should definitely read this book. It's Ryan Hux. It's called Culture. Um, and there he has this page where he says that we're at the very beginning of recorded history. And basically what he's saying is that 100 years ago, not even kings and the richest people on earth had as many images, as many media about themselves as everyday citizen nowadays have. And this is just truly fascinating to me that we now live in a world where this kind of notion of the self-image, of the preservation of media became so different. And what does it mean? At the same time, in the same book, there's this image which also fascinates me, which says we have all these different kinds of mediations, and somehow they became all the same. We managed to turn them all into this one device, which is basically the ultimate meta medium, are the ones and the zeros. So data becomes something that can represent all other mediations, from text, image, sound, video, to statistics, networks, complex systems, to health data, finances, sciences, society, friendships, to our Tinder apps and our love life with that. This is a quote that is now 250 years old from Charles Babbage. He was an inventor of a machine called the analytical engine. And he was basically 150 years too early with his invention because he was the first one who came up with this notion of a computer. And he wrote, "It is the science of calculation which becomes continually more necessary at each step of our progress, and which must ultimately govern the whole of the applications of science to the arts of life." But this is also something that makes me stop. And I'm wondering, the science of calculation should govern all of our lives. And what does it mean? Is this actually what we want? And so at the same time, it was not only like this notion of the fascination for data, but also some kind of fear. What is happening here? So 2012 was the first year where I requested all the data that Facebook had about me. You were able to request it. It took a week or something. And then they sent me back this document. It was like a PDF of a couple of 100 pages with everything they had about me. And I was wondering, is this something that I want a company to have, like all this information about myself? At the same time, also the web was much more open, and there were this like websites where you could plug in your Facebook data and you get back this graphs. It's called touch graph. Nowadays, it's like not. Since the revelation of the NSA of Edward Snowden, this became impossible to do. But it basically placed you in the center and then showed you all your friendship clusters and the connections you had. And this was something that I wrote down, that that basically, to be part of this ecosystem, of this idea, you have to hand over your personal privacy. And it's kind of unclear who owns these things. And this was, again, in the pre-Snowden era. And nowadays, it became even more evolved. This is also a quote that I was very much impressed by, that within 3 minutes, the global internet is processing as much data as all movies ever made. And that was in 2016. A French philosopher Paul Virilio said that the invention of the ship is also the invention of the shipwreck, that the invention of the plane is also the invention of the plane crash. And it's kind of unclear what the invention of the internet still is for us to bring, and what will the plane crash of the internet will be. So that is kind of the field of tension that I'm interested in. On the one side, like design and science and this connection between these two, and then this fascination for what data can do and what it's capable of, but also some kind of fear what it means for us. And this, I think, is like a very good mode of working within this field, or what drove me at that time, these kinds of questions. And I think all these different first things that I showed you, these first projects, what they all have in common is that they basically take data and turn data in some kind of pattern, turn it into a representation. And that became what I was interested in when I started to do. So what this means is that data normally comes in this really prescriptive kind of notion, and then you take that and you turn it into something visual that you can see. And one of the first works that I did during my studies was that I used this list from Forbes magazine. They basically every year release a list of all the billionaires that we know of that live on planet Earth. And they publish it in this kind of format where they're basically ranking the people and how much money they make. And I took that data and turned it into a graphic where I'm saying that connect all the countries together, and from all the countries connect all the industries, and then connect all the individual billionaires to one another. And it became this like tree diagram. And what you can see here is like that 1/3 of the billionaires, they're from the US. And then you can see that the biggest cluster is basically the United States banking sector. I also colored them in by if they're self-made billionaires or if they inherited their wealth from their parents. And suddenly this thing that was before a list that you could scroll through and where you could see like, oh, who's the richest person in the world and who's the second, becomes something where these patterns become visible, and you're able to find the country that you're interested in, and they're like narratives open up by doing this. Yeah, so the blue lines represent that somebody made the wealth by themselves, and the red ones are basically got that money from their parents. And after my studies, I moved to Boston, to the United States, and this is basically an image that shows the campus where I first ended up at Northeastern University, and I started working with a network scientist, with a physicist called Laszlo Barabasi at the Center for Complex Network Science. And just to give you an impression, like one of the projects that we did was we worked on the citation networks. So scientists, for a lot of them, like the way they see how powerful they are or how influential they are is by looking at how many connections, how many people reference their work they were they have, the writings they have. And we worked on a project where we basically not looked at this on the level of the individual, but on a larger scale. So each of these lines is like one person, and then you can select them, and you see that each individual publication is highlighted, and you can read up about that publication and what it is. And the higher the bump is, the more citations they became or they got for that paper. And we did something special in this case. We did not locate the papers where they were actually written at a time, but we placed them always at the same distance behind one another. And by doing that, it basically removed all kinds of patterns. So it became this randomness. If you look at like thousands of researchers or 100,000s of researchers, there's no pattern in when your most cited work will evolve. So for everybody who is a researcher in the room or who's striving to be a researcher, don't give up. There's always hope. So your biggest hit is still possible to arrive. So what you see here is chemistry, and this here is ecology. So we see that there's no pattern in any kind of field, which is pretty fascinating. And visualization and turning data into this graphic representation can help to showcase these kinds of things. Another project that we worked on originated at a lab at MIT, where they basically ran the largest simulations of the largest structures of the universe that we know of. So what you will see, every point is one galaxy. So within the simulations, within this modelings, the entire Milky Way is represented as one point. And then they run this and basically recreate it with the knowledge we have about the universe. And they run this through the 13 billion years that the universe exists and see how this structures, how this patterns evolve. And we got this data set, and my colleagues basically added in a level of network, very simple network statistics. So connect everything that is in a fixed range, or connect everything that is dependent on gravity. And then a third model, it's like a very well-known method called nearest neighbors. And we did that, and my colleagues were interested in how good can these models predict reality, and how are there any correlations that they can determine? And they worked on that with like giant computational systems. But I thought it's also interesting to visualize this data, and it actually turned out that this is the interface. You can find it online, so it's something you can do by yourself. And it actually turned out really beautifully to look at these different models and compare them and zoom in and filter through this. And for my colleagues, it was like really helpful to, on the one side, see the different models. On the other side, there's something in network science called the giant component, the moment when everything connects to everything else. And they were interested in when is this happening within the cosmic web, and where is it happening, or where is it happening at the later stage. And this visualizations actually became really interesting for them to figure that out. What I found fascinating about this is that the simplest model, the one that used the least computational forces, was, in my opinion, also the most beautiful. And it had the best correlations to the observational data. So there was some connection between those things. And we actually published this on the internet, and it became quite successful. So we had this week where we got contacted by all these magazines and outlets, and it became this like big thing. And it was pretty cool that like actually something that is normally hidden in a scientific lab and that is not visible to other people, especially like having these different models and choosing between these different models. That's nothing that usual citizens have access to. And suddenly through this visualization, that became something that they were able to do by themselves. But the internet, how it works is that we have this 1 week, and things are crazy, and you have this staggering number of clicks, and you have all these contacts from the media contacting you. But then after that, nobody's interested in that website any longer. So clicks went down very rapidly, very strongly. But then a couple of weeks later, the page views rose again, but we did not get any requests on the internet or like people like asking us for interviews. And I was wondering what's going on, what is happening, where are these people coming from? And so I looked into it, and I looked where this is like coming from. And one of the pages that we found was this one. And they all look quite similar. And I was like, okay, I don't know what it says. And then I translated it, and it said, results of the universe from the standpoint of God. And then suddenly I went through like the YouTube comments, and I found more pages, and I had found like all these things that said something like, perhaps the universe can be thought of as God's brain, or other people put it a bit simpler, we live in brain. Or other people had like an artistic perspective on it and said, God apparently thinks he's Jackson Pollock. And my colleagues were quite worried about this, and they were like, Kim, can we stop this? Like, what is happening? This is not, they are like misinterpreting the research that we're doing. But I was kind of captivated by this. And I asked myself, what is actually happening here? So this work that was in like the scientific bubble somehow got captured in a completely different context, and somehow had this like really different imagination was created. And to me, it was a real turning point, I think, that it's not just about the data, not just about the visualization or the patterns. It's also about the ideas, the culture, the beliefs of the people interacting with the visualization. The scientists looked at the visualization in a certain way, but other people did so too. The brain and the universe, they don't look the same by themselves. We make them look the same. We, as the designers of these images, have a very powerful position within this. The people who come up with how things look like and how things are structured. So I became more interested in what does it mean to work in this context, and what is the message that we are actually telling. There is a very fascinating article by Peter Gallison, who is a science historian. The article is called Images Scatter into Data, Data Gathers into Images. And he reduces that paper into this one sentence. We must have images, we cannot have images. And that scientists over the last 100, 200 years are struggling, or even longer, struggle with this problem of representation, of showcasing their science, showcasing their ideas, but then always figuring out, I cannot showcase the ideas. It's like a simplification. It's like removing what it is. And that became like a fascinating topic for myself. So I moved a bit away from this pure notion of this representations of patterns. The South African artist William Kentridge said, it's how we make sense of the world, not how it is. And I think in that sense, other things came into play and into my making. One of them is definitely perception and perspectives, how insights render into sight. And at that time, it was like 2016. I was still living in Boston, but I was on my way to move back to Berlin. And this was a screenshot I took from the New York Times website on the evening of the election. The week before, the New York Times had this needle where they forecasted who will win the election. And for weeks, it said that the chances of probability that Hillary Clinton will win the election was over 90%. And it was always like a modus for myself when I thought like, oh my God, maybe Donald Trump will win this election. I was like, no, I visit the New York Times website and this needle tells me like there's no chance. So I was always very I felt safe, and I took that screenshot and then went into the room, and with my other colleagues, we watched the election results, and this needle just flipped to the other side. And for me, this is a visualization that is hiding almost everything. It's like representing one number, but all the models, all the ideas, all the thoughts that go into this statistical thinking are hidden, are not visible. And that became something that very much drove my research since then. So this idea of mediation, what is actually happening here? I started a position at Harvard University on the one side, and on the other side, at a lab called the Meta Lab. And at the same time, I started my PhD at the University of Potsdam. And I think my work kind of shifted at the same time to some degree. This was a theater project that I did with a production team called Double Lucky Productions. The play is called The Hairs on Your Head Are Numbered. And what we did is that about half the audience that visited the show got a glove, and we captured their heart rate throughout the show. And you had on this glove, you had a number, you had an ID, and we basically throughout the entire show displayed the heart rates of the people within the audience. And then they had to do different things. And the goal of the play was to synchronize all of our heart rates to have like all the same heartbeat at the same time. And they had to run and had to sit down and be quiet. And the entire play, if people were too bad with the heart rates, they get thrown out of the glove club. And so it became this entire play with the audience, live capturing their data and displaying it and playing with that data. So for me, a question that I got interested in is if everything becomes data, if all we're capturing the entire range of life, what are we missing? What do we overlook? What cannot be calculated? And what kind of reality will be forgotten that cannot be digitalized? I very much enjoy this graphic by Lewis Carroll from The Hunting of the Snark. And it's a map without a distinction. It's a map that of the ocean that is not having a representational layer. And he writes, he had bought a large map representing the sea without the last vestige of land, and the crew were much pleased when they found it to be a map they could all understand. At the same time, I got interested in something like this, or research topics like this. This is a coastline paradox by Lewis Fry Richardson. It's a thing they found in the 1960s, and they figured out the shorter the measurement is, the longer the distance of a coastline becomes. So observation somehow influences how something is measured. And I think the same is true for the social networks, for the digital systems that we're using. It's very much the scope of possibilities determines what kind of distinctions we can make. Facebook only allows for 6 emotions. On Tinder, you can't say like, oh, I like that person a little bit, but you can only swipe left or right, which does something. On Twitter or on X, you can only like or retweet something. So, and what kind of determinations is that creating? In 2020, we got invited to a grant from the Schlesinger Library at Harvard. It's a library that deals with the history of women in America. And since 2017, they collected every tweet with the hashtag #MeToo. And they had a collection of over 30 million tweets. And while we were writing the grant application, I thought of something like this. It's a project by Jer Thorpe for the New York Times. And what you see here is like in the center, you have one article from the New York Times, and you see like this explosion of like all the comments on social media sites, how people reacted to that one article. And I had something in mind that was similar to this. So I wanted to know if somebody tweets on the topic of Me Too, how are actually people commenting on that? How do they act upon that? And making this discourse visible, how people talk about this topic. Are people like, is it only hate messages, or are people like friendly, or what kind of discourse is happening? And we won that grant and had the chance to work on this. And the very first thing we did was we took a random sample of 1 million tweets from 2017 to 2020, and we looked at all the tweets with more than 100 retweets, so only the ones that had like quite large number of interactions. And first of all, from 1 million tweets, that meant that only 892 tweets were actually making it into that list. And that was a small enough sample that we could read through all of that tweets. And of those tweets, about 100 or 153 of them were actually violating the rules of Twitter at that time. They all had the same number of retweets, so I was pretty sure that this is bot activity. So a lot of the content of Twitter, actually, we figured out, was based on bots. Then they also had tweets that were not longer available because of violations of the platform rules. And we had a lot of political tweets, a lot about Donald Trump, about Brett Kavanaugh. So those also came up. And by reading this almost 900 tweets, in the end, only 9 of them were about people that shared their story about sexual abuse, sexual harassment, allegations, sharing stories, what happened to them. And this made us very surprised that there was so little discourse about the topic that the actual data set was about. It was virtually non-existent. So making this discourse visible became impossible. And that turned us into another direction. And Catherine D'Ignazio, Cole Martin, Matthew Battles, and I, we built this interface that allowed us to read actually tweets. And we made like different collections of tweets that nobody ever commented, that had no likes, that had no retweets. And we made these collections and looked through them and basically created our own data sets from that. And one of the interesting findings that came from this is that Me Too is not networked. The tweets that actually contain this really horrible content at times had no comments, they had no likes, they were completely ignored by the systems. And in data science, it's a very common thing to get a data set and remove the things that have no connections to anything else. In network science, it's very usual to work what we call with a giant component, so with the thing that has connections, and the things that don't, we throw them out. And in this case, by doing that, if we would have done that, we would have missed like the entire data that actually mattered for the project. Later, after we finished the project, we actually found out that Twitter had a filter for people not to see the tweets. So because they didn't want engagement on these really horrific stories, they didn't want people to see them. But just imagine you're a person who had like something horrible happen to, and you shared that online, and then there's no engagement. Nobody reacts to that. So what we did is we created this set of visualizations where we visualized the data that we found that nobody ever looked at. This was a visualize, so we visualized the non-network, the things that are not connected. There were more than 80,000 tweets in that archive with less than 7 characters. So they only said hashtag me too, hashtag me too, hashtag me too, without any further explanation. They're acts and witnesses of solidarity, of silent acquisition, and the resist to compulsion to share details for media consumption. There was a hashtag called Why I Didn't Report, where people really shared horrible stories about what happened to them. And we only found out a very small number of tweets. I think in the end it was 9 that talked in the context of Me Too about indigenous cultures. So it was almost non-existent within that fear. And then there was a last visualization we made on the 15th of October, 2017. On that evening, the American actress Alyssa Milano was supposedly doing the first tweet of Me Too. And we just collected tweets that were already happening before that, of showcasing that the movement was actually building up for much longer than that. So what if there are cases where the important thing in a network are not represented by the points and the lines that we abstract it as? What if we're missing a certain dimension within that? What if the net is not what we think it is, but maybe it's rather the negative space it creates. Maybe the thing is rather in between the nodes. Maybe it's a structure that it fills, the holes, the non-spaces, the emptiness, the in-between. Community could exist in the non-networked, in the gaps between the lines that are filled in, extracted, and improved. So in the end, I made these drawings that don't show the network itself, but they show basically the things where the network has been, where the network appeared, but you only see the traces that the structure leaves behind. That brings me back to the diagram that I showed you in the beginning. And I think it still, for myself, very much holds true and shows something that I'm interested in. There's still like a fascination for data, and it's a medium that can change things and brings a lot of things into the world. It's still a very strong force that can connect fields, that can connect the humanities, that can connect design to science. And there are also still fears about it, what it will do to us as a society. I have 2 more projects. I can maybe show one. I'm not sure how tired you are, but okay, though, so I will go on. So one of the topics that like fits pretty well through this slide is the notion of climate and how to deal with climate. And I was fascinated when I read this quote from Arthur R. Jensen from the 80s, where he said that when they first invented or came up with this idea of measuring temperature, that like the philosophers at the time in the 16th century said there's no way you can measure something as complex as temperature in one number. Like, how is that supposed to be happening? It's such a complex phenomena, you can't do that. And it's something that we take for granted nowadays, that you can't do that, and that we can say, oh, outside it's 20 degrees, and everybody knows what that means. So this idea at the one side where we have this colossal problem with a climate catastrophe and how to deal with that. On the other side, we have this like agreement on technological sensing that might not really correlate with how we understood weather. There's a museum and an art space called Center for Arts and Urbanistic in Berlin. They basically invited us. They installed an antenna to capture weather data, and they invited us to work with that data. And we got our hands onto the data set, and actually they don't capture data in one dimension, so not only temperature, but they came up with like, or this antenna is capturing 63 different dimensions of weather. Here you can see all of them and how they look like. And in the end, what we got our hands on is like is the data set of that. So every minute creates one recording, and they're doing that for now over 2 or 3 years. So it's like this giant data set that lives on the World Wide Web. And we as MetaLab got involved into that project and trying to find new ways to narrate this data. And the first thing we did were a set of visualizations where we took that data and made graphical representations of it. A colleague of mine, Giacomo Nani, did a very wonderful and poetic version of this, where he basically tried to recreate the sky above the museum based on those readings. And we had an exhibition every 2 months. So over a period of like a year, we were able to also experiment not only with what we were doing, but also to showcase it in what they call open house. And apart from this visual experiments, we created this kind of questionnaire where we looked at how do people actually think the weather is, and then compared that to the readings from the sensor. So it's like this questionnaire that you go through, and you can say how warm it is and what is the UV intensity, how much rain has been fallen, etc. And then we could correlate that with the readings from the sensor. And we came up with this very simple line chart where we displayed the sensor values over time. And then increased the thickness of the lines if the sensor readings diverged a lot from what the humans said the weather is. And in the end, like for every questionnaire, we had a graphic that looked like this, where we compare the things to one another. And then we basically came up of turning that into a visceral bodily experience that is playful, abnormal way of dealing with data on basically placing it onto your own skin. These were non-permanent, so it's like this little tattoos that you got as a kid. They lasted for a couple of days because they were so big. It became really sticky. I went to a conference and gave a talk like 3 days after I got a tattoo, and they thought I had an accident or something because it started to look quite strange. So this is a diagram I made. So we have this phenomena of weather, and then we have the sensor, which is turning things into a database. But on the other side, we have this human involvement of the interface, and they come together in the visualization and in the tattoo. And what I found interesting about this is that this database and this level of the sensor that's like abstract and it's hidden to most people. And then suddenly you have this moment where people stand in front of the interface and looking outside because they have forgotten how the weather was when they got into the gallery, trying to figure out what to fill in into the questionnaire. And the end was this was part of the Berlin Art Week, and we had this dentist chair where people sat down and got their weather tattoo. I think in the end we had over 400 participants who got a tattoo. So the idea is to bring back the complexity, the subjectivity, and the interpretation of environmental phenomena and bring us back closer to what weather actually is. And also connect us to the abstraction and to what lies behind the surface of data. Here's a little video that we cut together on this. I think you get the point. So, and then lastly, something that I've been working on or spent like I think the last 3 years of my research very intensely on, but also before that, MetaLab is like dealing with this like question of AI. We've been working on it for the past like 10 years. And it's like one of these topics that is crossing like from fascination, how is this possible? What is actually happening here, to the fears of what will this do with society? And as somebody interested in data, one of the first things that I did or realized that is ChatGPT is not only giving you back text, but it can actually produce data sets, like small tables of content, of connections. And I came up with these questions of like, okay, give me a categorization of what knowledge is. And I gave it this like big topics. And what came back were this like lists, this really long lists of topics and subtopics. And this reminded me of like short stories from Borges or Kafka, the strange categorical creatures of inclusion and exclusion. Why is wildlife part of travel and budget travel and cultural experiences, but other terms not? Like I could come up with so many terms that fit this description. How is the system like including something and how is it excluding something? So that became something I got very much interested in. And I came up with this like way of not only question or requesting categories and subcategories, but from that asking about humans that are important in that realm, and objects, things, and ideas. And I made repetitive requests on the API in the end, about like 1,800 requests, and I built up this like giant data set from ChatGPT on the topic of knowledge. The smallest category within that is the category of nature. And I use this as an example. So I request like objects, things, places, and humans, and then get back have also the subfields. So I'm like for every field and subfield, I'm requesting these things, and I get back this list of items from that. So I have this like big set. And then I also ask always like, okay, what other related items are within that? And from the structure, I was able to create this like hierarchical network, and basically made a force diagram where all the points that I asked for, they repel each other, and if they are connected to one another, they draw together. So I was able to create this mapping of knowledge and the different categories. The outcome of this is a map with like 4 layers. So on the first layer, we have the categories, and we see that things that are closer together are more related to one another. So, for example, travel is connected to sports and nature and animals, and technology is connected to science and business and education. Then we have the subcategories. They're not that visible because they are like over 600, the items and the related items. And this is the final map or the final outcome of this. It's also a web-based project that you can visit. It's called Artificial Worldviews. And it's basically this map of the algorithmic conversations that I had with ChatGPT. And what fascinates me is that machine learning is often referred to as this black box. But we can actually access this black box pretty easily by talking to it. And individual queries can only lead to anecdotes, but structured inquiries in large quantities can actually give us some idea what the system produce and how they act. And so the question that I'm asking myself within this project is, if this is a list of actors, who determines what distinguishes, why is it this list? So what are the normal things that the system gives back if we don't give it a specific set? And who is making that decision? And I think it's a lot about the power structures behind the systems of the humans, the data, and the algorithms that come together in the structure of this. I also asked GPT for the humans, for the gender of the person. And as we see, men are basically named 3 times more often than women, and any other category is almost ignored. And projects like this can open up, do we want this? Is this the system that we want as society to, if these systems take up the production of text more and more, is this what we actually want this to be? And I think visualization can be a very strong medium to negotiate these kinds of things. What you see here is the list of the 26 most frequently named things, ideas, and people. And I would like to draw your attention to just 4 points. First, the list only consists of people. Second, 23 of the 26 people are male. Third, the 3 women are all at the top of the list, in between Aristotle. And the list is led by a zoologist, biologist, science journalist, and non-fiction author whose magnum opus, Silent Spring, from 1962, is often cited as a starting point of the US environmental movement. But nobody can explain to me why this list and why ChatGPT is naming Rachel Carson so much more often than any other human. And this is something I think this map can open up and question why certain things are represented or not represented. Data is actually the Latin term for the given, but I don't think there's anything given about data. Johanna Drucker, therefore, said we should rather talk not about data as a given, but about capta as a taken. But I'm actually like working with data. I'm not sure if it's really taken. Therefore, Bruno Latour rather suggested not to talk about data or capta, but about factum, the created. And from my perspective, data is always designed, performed, and acted. It's something that we shape and we determine, but therefore it shapes us back. It makes us into what we are. So we design data, and data designs us back. And I think this is like an ontological approach to data, where things are not given in the world, where it's not something deterministic that we cannot do anything against, but something that we should work and shape and determine what we want this to be. And with that, I thank you very much.